वेलकम टू सूर्यवंशीज मैथ्स एकेडमी स्टूडेंट्स। आज हम सर्कल के चैलेंजिंग क्वेश्चंस का सेकेंड पार्ट देखने वाले हैं। सी द सम AB is equal to AC, chord AB is equal to chord AC. Line M is parallel to tangent, touches at point A, and using this we have to prove AD is equal to AE. Students, we know if AB is equal to AC, these two angles will be equal to each other. This angle would be equal to this angle. Angles in alternate segment theorem, or you can say tangent secant theorem. This angle is equal to this angle. Same reason, tangent secant theorem. But we have to prove AD is equal to AE. We know line M is parallel to line PQ. So this angle will be equal to this angle and this angle is equal to this angle. If these two angles are equal, we can say AD is equal to AE. See how to write. We know AB is equal to AC given. Therefore, angle ABC equal to angle ACB. Isosceles triangle theorem. But angle ABC is equal to angle CAQ and angle ACB is equal to PAB or BAP, you can say. This angle is equal to this angle is equal to this angle. Tangent secant theorem. So suppose this is number 1, this is number 2, number 3, ABC, ACB, ABC, ACB. I will write CAQ is equal to BAP. Therefore, angle CAQ is equal to angle BAP. CAQ is equal to BAP. But students, we know this line M is parallel to PQ. So this angle is equal to this angle is equal to this angle, alternate angles. But line M is parallel to line PQ. Therefore, angle PAD is equal to angle QAE. Angle PAD is equal to ADE. Instead of PAD, you will write PAB also. Angle PAB is equal to ADE, and angle QAC is equal to angle AED. This is from 1, 2 and 3. Suppose this is 4, this is 5. Before that I will give this as a 4, this is 5, this is 6. Now see, CAQ is equal to BAP. CAQ is equal to BAP, so I will write AD is equal to AED. Write the reason, alternate angles, or you can write alternate angles theorem also. So therefore, angle ADE is equal to angle AED from 4, 5 and 6. ADE is equal to AED. If these two angles are equal, I will write, therefore in triangle ADE, AD is equal to AE, converse of isosceles triangle theorem. AD is equal to AE. We got a required proof. So next sum, O is the center of circle and segment AB is the diameter. tangents at point C and B intersecting each other at point D. In this situation, we have to prove segment OD is parallel to AC. For proving OD is parallel to AC, we need to prove these two angles congruent. Students, if you take OA is equal to OC, before that we'll do construction. We'll draw segment OC, draw segment OC. So see, in triangle OAC, you will take OA is equal to OC, radii of same circle. So this angle will be equal to this angle. After that, we'll prove these two triangles congruent. OC is equal to OB, radii of same circle. This is common side and this is each 90 degree. Tangent is perpendicular to the radius. Or you can take CD is equal to DP also by SSS test or hypotenuse side test. You can prove these two triangles congruent. After proving these two triangles congruent, you will write this is Y and this is Y because corresponding angles of congruent triangles. Now see, if we prove X is equal to Y, then we will be able to prove AC is equal to OD by alternate angles test. See, in triangle OAC, we know OA is equal to OC, radii of same circle. So angle OAC is equal to angle OCA is equal to X, isosceles triangle theorem. Suppose this is number 1. Now we know segment OB is perpendicular to line DB. At the same time, segment OC is perpendicular to line DC. Tangent is perpendicular to the radius. Tangent is perpendicular to a radius. So in triangle OCD and triangle OBD, we know OC is segment OC is equal to segment OB, radii of same circle. Segment OD is equal to segment OD, common side, and angle OCD is congruent to angle OBD, each 90 degree. Therefore, triangle OCD is congruent to triangle OBD by hypotenuse side test or hypotenuse side theorem. Now, after proving these two triangles congruent, you will write angle COD is equal to angle BOD, which is equal to Y, say, corresponding angles of congruent triangles. Now students, we need to prove this angle is equal to this. I will write angle COB is equal to angle OCA plus angle OAC. This is exterior angle of this triangle. This angle is always equal to this plus this. Remote interior angle theorem. You will write reason, remote interior angle theorem. So COB is Y plus Y is equal to X plus X. OCA is X and OAC is also X. X plus X. 2Y is equal to 2X. 2 cut. Y is equal to X. Y is equal to X. So I will write angle OCA is equal to COD. We got alternate angles which are congruent. Therefore, line AC or segment OD is parallel to segment AC. Alternate angles test. Angles test. AC is parallel to OD. Understood, students? In next sum, students, one triangle ABC is given in which angle C is 90 degree. In circle of this triangle is given whose center is O. Side opposite to A is small a, side opposite to capital C is small c, and side opposite to angle B is small b. Now, and radius of this circle is given R, and we have to prove 2R is equal to A plus B minus C. Now see students, if I draw OP and OR, this is the construction part, I will get one quadrilateral. I will say OP is perpendicular to AC and OR is perpendicular to BC. So this quadrilateral is a rectangle because 1, 2, 3, 3 angles are of 90 degree. Now, if this is rectangle but OP is equal to OR, radii of same circle, so this quadrilateral becomes square. So all the sides of square are equal. If this is R, this will be A minus R. If this is R, this will be B minus R. Now, you know, lengths of two tangent segments drawn from the exterior part of circle are equal. So BR is equal to BQ, which is equal to A minus R. Again, if this is B minus R, this will be B minus R. Tangent segment theorem. So if you add B minus R plus A minus R is equal to C, then you will get required result. See, in quadrilateral, you know, segment OP is perpendicular to line AC or side AC. Segment OR is perpendicular to side BC. Tangent is perpendicular to radius. Tangent is perpendicular to radius. Therefore, in quadrilateral OPCR, angle OPC, which is equal to ORC, is equal to 90 degree. Angle C is equal to 90 degree. This is given to us. Therefore, remaining angle will be equal to 90 degree. Therefore, quadrilateral OPCR is a rectangle. But students, we know OP is equal to OR is equal to R, radii of same circle. So this quadrilateral is a square. So all the sides of square are equal. Therefore, CR is equal to PC is equal to R. After proving this quadrilateral as a square, after getting value of CR is R and CP is R, we can find BR and AP. So therefore, BR is equal to, you know, this is A, this is R, this would be A minus R. Similarly, if this is R, this whole length is B, so AP is equal to B minus R. You know, but BR is equal to BQ is equal to A minus R, and AP is equal to AQ is equal to B minus R. Tangent segment theorem. Tangent segment theorem. So, you know, AQ plus QB is equal to AB. Therefore, AQ is B minus R plus A minus R is equal to C. That is A plus B minus 2R is equal to C. A plus B minus C is equal to 2R, and 2R is equal to A plus B minus C. और स्टूडेंट सी हमें क्या प्रूव करना था? 2R is equal to A plus B minus C. 2R is equal to A plus B minus C. This is the required result. Next sum. See, there are two circles which are touching each other at point A. Chord AB intersect this circle at point E, and chord BC touching this circle at point D. This is the common tangent intersect BD at point M. In this situation, we have to prove AD is the angle bisector of angle CAE. ray AD is an angle bisector of angle CAE, it means we have to prove angle CAD is equal to EAD. For proving these two angles, students, if we take this angle as the x, before that, you know, MA is equal to MD, MD is equal to MA, tangent segment theorem. So angle MAD is equal to MDA, isosceles triangle theorem. Suppose this angle is x, then this would be x. Now I took this as a y. If this is y, can I write, if this angle is y, angle CAM is y, can I write angle ABC is also y? Tangent secant theorem. Now, you know, if this is y, this is x, exterior angle property or the remote interior angle theorem, you can write if this is x, this is y, this would become x plus y. So angle CAD is equal to, as I told you before that, CAD is equal to x plus y, x plus y. So what is the measure of EAD? देखो EAD क्या होगा? x plus y, remote interior angles theorem. So EAD का measurement x plus y, CAD का measurement x plus y. So can I write EAD is equal to CAD? Yes, both are equal only. If both are equal, then AD is the angle bisector of angle EAC. AD is the angle bisector of angle CAE. ये हमें प्रूव करना था. So next sum, students. O is the center of circle, tangent AC and tangent DB intersect at point P. Angle P is 60 degree, and we have to prove. Before that, they have given AQ and DB are the angle bisector of angle CAB and DBA respectively, and we have to prove triangle PAB is congruent to QAB. It's very easy to solve, students. You know, if this angle is 60 degree, PA is equal to PB because tangent segment theorem. If this is 60, suppose this is x, this would be x, isosceles triangle theorem. So you will be able to find angle x or angle B or A. So you will get this as a 60, 60. See how to solve. You know, PA is equal to PB, tangent segment theorem. So angle PAB is equal to angle PBA is equal to x. You know, in triangle PAB, angle P plus angle PAB plus angle PBA is equal to 180 degree, angle some property of triangle. So 60 plus x is equal to 180, 2x is equal to 120, x is equal to 60. So we got two angles, angle PAB is equal to angle PBA is equal to 60 degree. 60, 60. Now we can find this angle as well as this angle by linear pair. See, therefore angle CAB plus angle PAB is equal to 180 degree, angles in linear pair. So CAB plus 60 is equal to 180. So CAB is equal to 180 minus 60, that is 120. Similarly, angle DBA or ABD, whatever you want, you can take. ABD is also equal to how much degree? 120 degree. ABD भी कितना रहेगा? 120 degree रहेगा. A 120. You know, ray AQ is the angle bisector of angle CAB. Therefore angle QAB कितना रहेगा? 120 का हाफ, that is 60 डिग्री. ये 120 का हाफ है 60, ये 120 है, तो ये भी क्या रहेगा? angle Q. Similarly, angle ABQ is also 60 degree. So we can prove these two triangles congruent. Therefore, in triangle PAB and triangle QAB, we know angle PAB is equal to angle QAB, each 60 degree. Segment AB is congruent to segment AB, common side. Angle QBA is congruent to angle PBA, again each 60 degree. Therefore, triangle PAB is congruent to triangle QAB by ASA test. So students, thus we have proved triangle PAB is congruent to QAB. Understood students? So students, सर्कल के आज भी हमने 5-6 सम्स देखे, आपको अच्छे से समझ में आए होंगे। वीडियो पसंद आया तो लाइक और सब्सक्राइब कीजिएगा। थैंक यू फॉर वॉचिंग दिस वीडियो। सी यू अगेन।